I want to move over to a different type of simulation here briefly. This particular simulation is going to have to do with thin wall geometry. Now I want to bring up an assembly of this situation, but the assembly is really a mixed situation. The assembly that we've got here is built with a lot of thin wall parts. Now those thin wall parts can be two different types of things. Down here we have surface modeling, so zero thickness geometry in effect, and then here we have a sheet metal part. Also thin wall geometry, but this one is solid. It does have thickness to it. So this is handled in a couple of different ways with this release. When we're setting up any type of a simulation using thin wall geometry, generally we're using shell meshing. And through the normal interface up to 2014, we'd always go ahead and create a study, and then with that study we'd go ahead and define the thickness of each of the pieces of geometry. And in order to see the thicknesses, you'd have to edit each body within the parts tree. Very difficult, especially to change things, especially when you're changing several things into a new value. So what we've created is this brand new thing called the Shell Manager. Now what the Shell Manager does for you essentially, excuse me, I want to do a different one there. What the Shell Manager does for you essentially is it gives you the one-stop shopping type of input, much like the Load Case Manager. It's going to show you the different bodies that are participating on the screen. We can see that these bodies can be grouped together, and those groups are effective when we're making changes. Each of the bodies, as we select them, will show up as a highlight on the screen, so it's very simple to see which body it is. And then very quickly we can see what the thicknesses of each of those are. Now things can be sorted based on these column headings, but you can also colorize them that way as well, which is not only going to color our shell tool, but it's also going to color graphically the geometry on the screen. So the manager column is going to go ahead and mirror exactly what we see out here for color-coded parts. And it's really effective to make changes as well. Not only can I see all the parts that are 5 millimeters, on screen they're all green, but most of them are part of this base lateral group. And if I was to go in there and change one of those from 5 to 6, you'll see that the entire group is actually about to change as a result of that one change. Pretty time-consuming before, but also very error-prone when we had to edit each of the bodies in order to make that change. So a great interface to make those changes, also some control over the type of geometry, whether it's thin-walled or in this case thick-walled geometry. Determine the thickness from that. Something that used to happen back in 2014 has also been addressed in a very nice way here in 2015. Here's a 2014 simulation of this particular file. And what would happen is on thin wall geometry like these sheet metal parts, these parts would be simulated without any type of bonded contacts to themselves. We've always had contacts from one part to another, but not amongst itself. So when we go ahead and do a stress plot or an amplitude in this case, this part would actually peel away from itself because there was nothing bonding this flap to this part of the sheet metal component. Well, now in SolidWorks 2015, those types of sheet metal components with adjacent faces are automatically going to get a global bonded contact. So in the 2015 simulation of this, if we look at the same parts, you'll see that that sheet metal part actually holds true and creates a much more sturdy representation of what that file is actually here to do. So a couple of really nice additions just in quality of study and ease of use moving forward with these tools here as well. We've also added a great deal within the system here for performance sake. There is a new solver. The new solver itself I don't have a lot of performance data on, but the new solver is just going to work for different use cases, and it is faster than the solvers we have currently, especially when it comes to more dynamic and nonlinear types of simulations. But what you can also do, regardless of the solver that's being employed, is